lifts a 5-kilogram puppy from the ground and does 10 joules of work. How far down is the ground?
5-kilogram puppy and 10 joules of work. To find the distance traveled, we're going to use the work equals force times distance traveled, delta x. We need to find that force by doing F force equals mass times acceleration. We know our mass is 5 kilograms and our acceleration is gravity 9.8. When you multiply those together, you get 49 for your force, 49 newtons. So now you plug that back into our first equation. So we have 10 equals 49 delta x. We divide by 49. We get 0.2 meters for our delta x. That is how far the person is from the ground when lifting the puppy.
We worked it out. We have a problem. Problem 2. A kilogram bowling ball moves 3 meters per second. How fast must a 3-gram ping pong ball move so they have the same amount of kinetic energy? A bowling ball. A ping pong ball. A kilogram bowling ball moves 3 meters per second. How fast must a 3-gram ping pong ball move so they have the same amount of kinetic energy? Let's work it out. 1, 2, 3.
8-kilogram bowling ball moves 3 meters per second. The 3-gram ping pong ball, which is 0.003 kilograms, we're trying to find the velocity. So we set up the kinetic energy equation. Kinetic energy equals 1/2 mass times velocity squared. When we plug in, we get KE equals 1/2 8 times 3 squared. We run out the numbers, equals 36 joules of kinetic energy. So we go back and we plug in for the ping pong ball of 36 kinetic energy equals 1/2 0.003 v squared. We divide, first we times 1/2 by 0.003 to get 0.0015. We divide that over. And we get 24,000 v squared. We take the square root, and we end up with 154.92 meters per second. And that is the velocity of the ping pong ball.
What do tigers dream of when they take a little tiger snooze? Do they dream of kinetic energy or working lots of joules? Thank you for tuning into Little Debbie's House of Physics. Tune in next week when we travel to Paradise Falls to calculate the velocity of Kevin, our favorite snipe. Here's Snipe!